Okay, maybe, just maybe we are live. No, no. Q. Let's see. This is just anyways a test stream. So screw this. Let's increase the font size, I guess. Let's see how OBS sees it. Now this is too big. This should be easily visible to everyone, I guess. Okie dokie. Cool. So our goal is to essentially write a kmeans function where we just need to write like a kmeans clustering function. We are given some points. We are given number of clusters. We are given maximum number of iterations and some initial centroids and so on. Okay, so we need to simply return the updated centroids at the end of everything. So I'm just gonna like return none for now. Okay, hold on. But before I do this, right, let's see if my stream is visible on other devices, because it's gonna be like a minute delay, I guess. Let's see. If I am streaming right now, how do I know if my stream is live? Right, like this should be easily. Hold on, let's see. Is my stream visible though? Okay, I'm guessing it is. I'm hoping it is. But okay, can I not see my own stream? Hold on. Your videos maybe. There's this one thing. No, this ain't the one that I want. How do I see my broadcasts? Like view channel. Oh, I'm live right now. Okay, cool. Testing. Okay, I'm just gonna leave a comment on my one stream. I just wanna test it out. Okay, cool. Mom can comment on her own video. Cool. So live stream seems to be working. It seems to be on right now. Let's quickly code k-means clustering. So cool. So I'm just gonna like create like a centroid dict maybe, which will be a default dict of tuples. And what I will do is I'll just initialize all the centroids for send in initial centroids. So I know that my initial centroids is just a list of two floats. So instead what I'm gonna do is I'm just gonna do for I in range of length of initial centroids. I'm going to use that I as the cluster, not cluster number as such, but just, yeah, maybe just cluster numbers, because we will have I equals initial centroids ka I, right? So this is just initializing our centroids. Now the strategy that I'm gonna follow is again the same thing that we did yesterday. Strategy boom for max iterations, right? For max number of iterations, what we need to do is go through all the points, figure out which centroid. Okay, this needs to be like nested. Oops. Which centroid is closest to the current point, assign it as the current center. Okay, assign it as assign that centroid's cluster number as the points cluster. That's what I'll do next. For all points, update the centroids. Cool. So this is what I'd want to do. This is just us initializing. So for what I'll do is, like, for something, a placeholder in range of max iterations for p in points. So we got to do something here, right? We got to do something here, and so what I will perhaps do is I'll figure out like a data structure in which I want to store my points. So I know that every centroid, every cluster will have a set of points. So I can just do cluster location equals a default tick with like a list in it. And what I will do is okay, so what I'll do is I'll write a distance function. I'm gonna call it like def dist function. I'll pass in point 1, point 2, and cluster number, and I'll ask it to return like some distance and again the cluster number. I'll explain why I'm doing this. Okay, so we can have points that are like in n dimensional space. So we can have like x1, y1, c1, and so on, and we can have two such points. So if you want to simply get the distance, we can simply do dist equals math, not math, we already have math. So we know sqrt, we need to have like a square root of, we're gonna have to have like a sum. In that sum, what I will do is I need to have the square of every point, the difference between every two ith dimension of that point. So I can just do like point 1's I minus point 2's I, and we do a square of this for for what is the issue here? Okay, got it. So I in range, let's just say L, where L equals len 0.1. So I'm just hoping that my points are always the same, both. I do not have one point in n dimensional space and the other point in n plus r dimensional space. I'm guessing that, hoping that's how clustering would work. So let's just see if this is right. So point 1, point 2, the ith element of that tuple, you're doing a square of that, taking a difference, taking a square of that, doing a sum of this, returning the distance, and essentially at the end returning the cluster number. So what I'm gonna do is here I will say I don't really care about the dist, but I care about the cluster number. And what I'm gonna do is like dist f of p and I'll just say centroid dict of say I for I in range k. So we know we have k clusters, we have k centroids. So in our centroid dict, we'll pass in our first point and we'll pass in every cluster. So this thing essentially returns the smallest. Not this, not this, not this. We need to do. This is essentially the list. This essentially returns the smallest cluster number, right? That returns the cluster number that is like closest to the current point, and I will simply do cluster allocation cnum dot append p. So that's how I'm doing my cluster allocation. And instead of keeping this global, I can just do it for every iteration, because every iteration my cluster allocation will update, right? So this is done. Now we come to this point. So for all points in my centroids, so okay, we'll get rid of this just to make it look a little cleaner, I guess. Now for, I guess, hold on. Okay, sorry, got distracted. Okay, cool. So we need to now update our centroids, right? So I'll just say, okay, cluster number, cluster points in cluster allocations dot items. So this is going to be like a dict, and we pass in. Okay, I'm just going to be like cluster num cluster points, just to not confuse two names, right? So for cluster number and cluster points, I'm just going to be like centroid dict of cluster number, cluster num, sorry, equals say centroid function of cluster points. So I need to define this, of course. So let's just go here. We'll just do def points, I guess. So this is going to be like a list, but what we need to return is like a tuple. So this is going to be an assignment, and at the end we'll just return a list of values. This should be our total function. Now let's do the centroid function. So again, we have x1, y1, z1, and so on. This is how our cluster is, I guess. So I'm just gonna be like len is len of points of 0, right? Just to get an idea of how many vectors we have in one thing. Num points is gonna be len of points, whoopsie, and we know that this is gonna be like a tuple, right? So new centroids is gonna be like a tuple of, let's just do like a round, like we'll do like a 4-place round, and this is going to have, for every point we're gonna have to average out the point. So I'm just gonna like points of I, right? So I'm gonna be like sum the points of I for I in range of num points. Hold on, no, this does not make sense, I guess. So for the first one, Oh, okay, okay. Hold on. So I need to do a vertical traversal, if that makes any sense. Uh, so if I do points I for I in range num points. Oh, okay. So this is anyways gonna be like a two-dimensional thing, right? So uh, I and then let's just say, okay, let's just call it row, just to, and we'll just do call, right? Uh, this sum needs to be divided by num points. Now this call that we see here, so this is cool for call in range L. Uh, this should like be right, I guess. So let's see if this is doing it, like if this is actually properly coded. L is the length, which is here, call is here. So let me just see the loops. For I in points, this is in a range, this is in a range, this is being used as a range, this is P being used here, cluster number, cluster points, cluster allocation, cluster items. This is fine. Centroid F is returning a tuple, which is this thing, which is essentially, okay, so if I see one element in this, it's going to be this round function. Round function has internally a sum, which is basically an average, right? This is what's happening here. Sum by num points. Num points is the total number of points, and this is essentially internal list is points row is just going vertically, call is just going like this. Okay, so let's just see if this works. Maybe, I don't know. Boom. Of course. Cluster num is okay. Of course, we forgot to pass one argument to our function here, which is I, right? We forgot to pass I. I'm sure